Okay guys, I'm going to do number 12, and then if I have time I'm going to do number 15 with you because I feel like it'll move things along a little bit quicker tomorrow. Also, some of this is going to help you with tonight's homework. So I'm going to go ahead and go to the calculator and enter in number 12. And you have it on your sheet of paper, and it's the actual number 12, not the renumbered. Like, don't renumber it. So it's 4x to the 4th minus 4x cubed minus 7x squared plus 8x minus 2. Okay, now we're going to talk about this some more in a minute, but I noticed that the constant is a 2, a negative 2, so I know the possible factors will be 1 and 2. The Lie coefficient is a 4, meaning the possible factors are 1, 2, and 4. So we have a little bit different situation here that we're going to deal with in just a second, and I will show you this. So let's go ahead and graph this, and remember to check your window starting at kind of middle of the road type of graph window range. So go ahead and graph it. Okay, I have a lot of extra space over here on the left and right, so I'm going to go into the window and kind of change to maybe a negative 5, 5. And then maybe the same thing for the y's, just to kind of zoom in a little bit more to what I want to see. So there's our graph. And it appears that it is crossing somewhere between -1 and -2. It also seems to be touching maybe at a 1/2-ish, and then somewhere between 1 and 2 as well. And then it's a degree of 4, which I do see 4 real roots here. I see 1 here that I'm circling. I see 2 here, and I see 1 more over here. So what I want to do is I want to explore the possibilities as to what our real rational roots are. So let me show you here. The possible rational roots are going to be plus and minus, and it's 1 and 2 over 1, 2, and 4. 1, 2, and 4. So what I want to do to figure out which ones I'm going to test or look at, I have to pair. So I want 1 over 1, 1 over 2, 1 over 4, that kind of thing. So it's going to be a plus minus 1 over 1, then matching 1 with 2 and 1 with 4. And then, of course, I move to the 2, and I have 2 over 1. 2 over 2, which is just the number 1 that I already have, so I'm not going to write that. And then 2 over 4, which simplifies down to 1/2. So I have those possible rational roots. So there's 8 of them. So going back to the graph, I'm going to see which ones I think it may be. So going back to the graph, I know that I have the possibility -1, we don't have that here. +1 we don't have. 1/2, this may be 1/2, and we'll test that in just a second. I don't have a -1/2. I could have a 1/4, and I don't know, maybe this is 1/4 over here, I'm not really sure. And then I don't have anything at 2, because there's 2, and I don't have anything at -2. So this is our only root that could possibly be a 1/2 or a 1/4. And remember how I showed you can go into second, calculate, and when I enter the value, let me just go ahead and try 1/2. So do 1 divided by 2, enter, and then yes, there is my real rational root. And it's actually a double root, so I'm going to actually use that root twice for synthetic division. Okay, so let's go and I will show you what I am talking about. Okay, so what I have here is one real rational root at 1/2. So I'm just going to make a little list for all my roots up here. So this is going to be a real rational, and furthermore we know it's going to be a double root. It's going to count for 2 of the roots that we need. And remember, we need 4 roots because the fundamental theorem of algebra states that we can have up to that many roots that are real, and we'll have exactly that many roots if we include the imaginaries as well. So let's go ahead and do our synthetic division, and I'm going to have 1/2, and then remember how when you have a double root you have to stack it, and it's just ironic, it's the same root twice, so I have to use it twice here. Okay, so what I'm going to do now is make sure I have all my terms present. I have a degree of 4, 3, 2, 1, and 0. So all my terms are present, so just use my coefficients. Okay, remember we said we can put a little 0 there just to make sure we know to just add that way. So here I get a 4 when I bring that down. 4 times a half is just 2. When I add here, I get a negative 2. Now, I'm going to get a negative because it's a negative times a positive, and 1/2 of 2 is just 1. When I add, I get a negative 8. Multiplying, half of negative 8 is negative 4. Add, I get a 4. Half of 4 is 2, and I get a remainder of 0, which I definitely should get a remainder of 0. So now we're just going to continue on with what we have here. Bring down your 4 or add it to the 0 if you want to think of it like that. Half of 4 is 2. Here I get a 0. Multiply 0 times anything is 0. Add, I get negative 8. Half of negative 8 is negative 4, and I get a 0 here. Now, I think you remember yesterday we talked about the fact that when your b is 0, you can actually just solve for this. I can write this as 4x squared minus 8. And I would set that equal to 0 and solve. And the reason I'm not having to use a quadratic formula is because my b is a 0. And in that case, I can just solve using square root. So I'm going to add 8 to both sides. And I end up with 4x squared is equal to 8. Divide both by 4. And I get x squared is equal to 8 over 4 is 2. And then I would take the square root of both sides. Don't forget your plus minus. X is going to be plus minus the square root of 2. Those are those two other irrational roots. I'll need to write those down. So a plus and a minus square root of 2. And they are real, but they are irrational. So the positive square root of 2 was on the right side of the graph. I'll just show you real quick. So this would have been the positive square root of 2, okay? And this would be the negative square root of 2. So they kind of match. They're symmetrical. They're opposites. All right, so let's finish this off. I need to also write the factors. So f of x is going to be equal to, and then I have this factor at x minus 1/2. And it would be squared because of the fact that it was a double root. So be careful with that and remember what we learned in the last unit. And then I'm going to write down here 4x squared minus 8. Okay, and this is completely factorized. There's actually something I can do here. So I'm going to go ahead and pull out a 4. So if you think of factoring out a 4, it would be 4. I just stick it out front. X minus 1/2 all squared. And then if I pulled out a 4 here, I'd be left with x squared minus 2. That is completely factorized. So it's a little bit different scenario there. And remember that we also need to write our linear factorization. So let's do that. And remember that we are using the fact that x minus r is a factor if r is a root. So this one right here is actually fine. It's really x minus 1/2 times x minus 1/2. So they're both linear. Okay. And it's different than this one. This is actually a quadratic factor. So this is not okay to leave it like this for the linear factorization. So what I want to do is look at my roots. The plus square root of 2 is going to be x minus the square root of 2. The minus square root of 2, which I have right here, is going to be x minus a negative square root of 2 makes it x plus the square root of 2. And that is the linear factorization of this particular problem. Okay, and the last thing, I need to stick the greatest common factor of 4 out front, and because I pulled it out up here, I need to also use it in this factorization. So again, this is what is considered completely factored, because we can't actually factor s squared minus 2. And then this is called linear factorization because every single factor is linear. So it's a different little twist to it. So just make sure you understand that. We'll go over it some more tomorrow. So I have number 15. So let's go and graph number 15. Now you notice that 15 has a degree of 5. So we're going to need to find 5 real roots. So let's go ahead and clear this out. And that's one reason I wanted to do this one with you. And also remember that if you don't have your graphing calculator at home, you could use Desmos. It works great for graphing these as well. So this is a long one. Let's get it all in here and double check it. So x to the 5th minus 6x to the 4th plus 10x cubed minus 10x squared plus 9x minus 4. So let's graph it. I'm going to go back and change my window. Well, I'll start with this just to see. Okay. Now, I see what's probably a root right there and probably a root right there. But let's double check that 1 and then 4. So remember, when you have more than one to check, you can go to the data table. And I see 1, 0 is an x-intercept and 4, 0 is also an x-intercept. And let's kind of look at the graph and see what's going on out further. It's just going up and up and up. You can see the y's are getting bigger and bigger. So we know that we have a double root at 1 and then just a simple root at 4. Now let's go back and let's look at our possible rational roots for this problem. Okay, so the possible rational roots are going to be a 1, 2, and a 4 over a 1 because the lead coefficient. So definitely the roots that we saw are going to work there. So what is going on? Like, why do I only see 3 roots? It's because the other 2 are probably imaginary. So let's go ahead and use the number 1 and the number 4 in synthetic division. But guess what? I've got to do the number 1 twice. So let's do that. So I'm going to do the number 1. And you can call this piggybacking, stacking, whatever you want to call it. And then 4. And the reason I'm using the number 1 twice, let me scoot this down, is because it is a double root. So let me start writing our roots out here. So I've got the root 1, it's double. I've got the root 4, and then both of these are going to be our real rational roots. Okay, so I'll abbreviate that, real rational. Now, I have a degree of 5, 4, 3, 2, 1, and 0. So I have every single term present, so I just need my coefficients. So 1, negative 6, 10, negative 10, 9, negative 4. Okay, and I'm running a little short on time, so I'm going to do this pretty quickly. In fact, I think I'm going to pause it and do this and then come back and show you how to wrap it up. Okay, so hopefully you did the synthetic division that we had set up, and hopefully it makes sense to you there. So you can see that I have the remainders of 0 where I'm supposed to have them. And if this was a degree of 5, remember that every time we do synthetic division, it's almost like we're taking 1 degree away, 1 degree away. So this is x cubed. So here is our x squared. So we actually have another situation where our middle term is missing. So we really have x squared plus 1 as the other factor. Okay, so what I would do with this is I would set it equal to 0 to solve. So I'm just going to solve on this. Could I use the quadratic formula? Yes. Remember we talked about that. But if you do that, it's more likely you'll make a mistake because this is pretty straightforward once you get to this point. I'm going to take the square root of both sides. Square root of both sides. Don't forget your plus minus. So this is going to be a plus minus I. So if you go back to the graph and remember what that graph looked like, we only saw 3 real rational roots, and the other 2 are actually imaginary. So those are those 2 roots. So we also have plus and a minus I, which are the other roots, but they are imaginary or complex roots. Okay, so